Warm welcome to the session, students. I hope everyone is doing good. Okay, let's start with the session. This session is about advanced encryption standard. See, this is a second encryption standard which we are seeing in the symmetric cryptography. The first one which we have already seen is a data encryption standard. See, after having data encryption standard, why we are moving to AES will be the first slides, whatever we are discussing about. I mean, the origin of AES and what is the main criteria which it is having. And all those things we'll be discussing in the first slides. And then immediately we will be moving to the AES structure. Coming to AES round and key generation, we will be seeing in the next session, right? Okay. Now, after having DES, why we need a DES replacement? Means there is, whenever we have some advantages, immediately we will be having few disadvantages also for few reasons. So those are the controversies which we have on the theoretical attacks on DES. So if we start on, keep on searching for few attacks on the count of 2 power 56, somewhere or where like we will be getting our key outside. So this may be a small disadvantage which we have on DES. Thus, we have the next version that is a triple DES, but using triple DES with 2 keys or 3 keys combination will be making our system slow and complex also sometimes. And these are like triple DES is very advantageous when we require a high confidentiality because no one can break this triple DES. And it will be very advantageous when we are utilizing with the small blocks of coding. When we need larger blocks of coding, then AES enters into the scenario, right? So first of all, how many AES, how many algorithms entered at the time of AES will be the short list of the AES. So at the time of AES, we have these 5 important algorithms which are entered into internet world or whatever we say. The thing is depending on how fast, efficient and secure is our algorithm is. So depending on these 3 criteria, there are 5 algorithms which are shortlisted in August 1999. After having this, Rijendel, Belgium, see third point, which we are seeing as a third point, is the AES algorithm. AES, the other name is Ridge and Dale, or else you can call as Raindale also. So this Ridge and Dale is a extended version. I mean the extended version of DES, where we have the key size as 128 bits. Plain text size and key size will be of 128 bits. Next, its extension is given to 192 and 256 also, for more and highly efficient, efficient and confidential data. Now, if we move to the previous slide, once, you can see 5 were shortlisted in August 1999. Then Rijendal was selected as AES in October 2000 by Phipps publication 197 standard, right? So this is a small talk about AES, how the history and the why and all things, right? So let us move with the cyber top view. I mean, this algorithm's top view is given as, see, a plain text of 128 bits and AES algorithm is a cipher. Next, cipher of output. I mean, from 128 bits input, we need 128 bits output. So input is plain text, output is a ciphertext we know. And now the key which we are applying will be ranging from 128 to 256. That too, 128, 192 and 256. Right. See, designed by Ridgman Damon. So that is a name given as Ridge and Dale. Okay. So this is a name given to AES algorithm. And now the key size will be of 128, 192, 256. And as this is the iterative cipher, iterative means the input, whatever we are giving as a state, will be given as a output. I mean, we'll be generating one output. And this output again will be giving to the input to the some other block. So we'll get some output. Again, this output will be given as input to the some other block. So this is a process of giving your data block as an input and output formats continuity in a continuity format, right? Then operations on the entire block will be run as with respect to the round format. So let us go with its format first of all. See, we are saying 128-bit plain text, right? So 128-bit plain text will be arranged in 4x4 ordered matrix. So where you can see here 4x4 ordered matrix where one block will be holding 1 byte of data. Okay, so that is nothing but 8 bits. Now 8 bits, 8 bits, 8 bits, 8 bits. So this will be giving you 32 bits. Got this? Next, this is 32 bits. Next, this is 32 bits. And this row is 32 bits. So overall, we'll be having 128-bit values in our 4x4 matrix format. Okay, so this is the first point which we have to know in the structure of AES. Before entering to the structure, we should know this basic point. Now, this is a data block, right? We have discussed about the data block of 4x4 matrix. Now, coming to the key format, you will be having only one array. See, only array. This is not a matrix. This is array of only one row where the first index will be holding 32 bits, 32 bits, 32 bits, 32 bits. So that you will be having 128 bits of key size. Got this? So this is about the key. I hope everyone got this point about how 128 bits we are storing in the plain text format of 4x4 matrix and how 128 bits key is stored in one single row array of 128 bits. So we are ready with our content now. Now next is the data unit. So how data is called, right? So when we say 8 bits, we call it as byte. When we say a word, see, a word. See, a word is a combination of, see how many bits? B0, B1, B2, B3. Now, this is nothing but 4 bits you will be calling as one word, where a block will be holding in AES will be with 4x4 matrix. Yes or no? So 4x4 matrix holding 88 bits each block. So that is the reason we got 128 bits. Now, a word you are storing as B0, B0, B1, B2, B3, B4 like this. Now, you will be having each and every word with the 32 bits combination. See, 32 bits combination. So each will be having 8, 8, 8, 8. So 4 bytes of data. So that is nothing but 32 each, right? So this is the state format of the plain text. This is the word format of the key format. So this is the next data unit which you have to understand whenever we are entering into this structure in the detailed format. So the same thing which we have seen in the previous block, we have given in the units transformation. That's it. So here the block data is given with, sorry, here the block data is given with B0 to B15 because we have 4x4 matrix of 16 blocks, right? So which will be varying from 0 to 15. So that is what we have given here. So that is a state, we call it as S00, S01 means row 0 means 0, 0, 0, 0 will be common and your second value will be incrementing from 0 to 3, 4 values, right? So in the same format, you will be maintaining in the block thing. So this is nothing but unit transformation of your data, which we have seen in the units data. Next is changing plain text to the state. How we are changing our plain text to the state is the second thing. See, whenever you have one plain text in your hand, see AES uses a matrix ZZ. See, AES uses a matrix ZZ. ZZ is added because you need, as we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, right? But the block size, the state size which we have is a 16 blocks, yes or no? So 14 minus 16 minus 14 is 2. So we need 2 extra padding elements called ZZ. Okay. Now, A will be represented as in hexadecimal 00. So like this, we keep on updating all the hexadecimal values to the plain text individual alphabet. Next, represent this 4, 4 in one column format. See, 4, 4 in one column. See, don't forget, this will be given in this format. 0, 0, 0, 4, 12, 14. 0, 0, 0, 4, 12, 14. Don't forget to mention the first 4 in the column format. Next 4 in the next column. Next 4 in the next column. So like this, we keep on posting our 12 block of elements in the 12 block of states. I mean 14 block of 16 block of elements in the 16 block of states. Got this? So this is about the transformation, how bits are 128 bits of data, 128 bits of key, how we are storing in the states and word format we have seen, and at the same time we have seen how plain text converted to the state format is the next thing. Next, last but not least in this is about the major summary and the structure format of your AES, right? So coming to the AES structure format, you should have the key expansion as just now we have seen 128 bits, how we have divided into the word formats and how we have saved in one array, right? So this is about a region-based key schedule. So we'll be discussing this in detail again in the next session. Next is the initial round. What is the major operation which we perform in the initial round? See, DES initial round is the initial permutation which we do, right? So in the similar manner, AES is also having the initial round. Just the thing is the add round key. So add round key is nothing but we just operate bitwise XOR. Nothing will be there. So we'll be discussing this. Next, how many rounds? So in DES, we have 16 rounds, right? In AES, we can have either 10 or 12 or 14 depending on the key size. If 10, 128 bits, 12, 192 bits, 14, 256 bits, right? So in every round, there will be 4 common functions which we are going to apply. So substitution bytes, okay? Substitution bytes is nothing but we will be replacing. So substitution cipher, just to remind substitution cipher. Shift rows will be transposition, means rearrange the elements. Mix columns. See, after having one state of 4 by 4 column matrix, row and column matrix with us, we will add some extra content, pad content. Okay. Next, at last, we'll be performing the XOR, bitwise XOR operation. So this is about the every round information. Now the final round will be mixed with the mixed columns. Remaining 3 will be as it is. See, substitution bytes will be there. I mean substitution ciphering. Next, shift to rows transposition ciphering and also the XOR bitwise operation, but no mixed columns in this. Got this? So after this, just we'll be discussing about this structure. See, whatever we have discussed over there is the similar points which we have given here also. Now the structure, see, just now we have seen this. See, 4 column matrix in the which will be comparing with the previous session. I mean highlights. Key is expanded to the words. Next, 10 or 12 or 14 rounds of information. What will be happening in every round? Initial round will be the XOR key. And the last also will be applying with the fast XOR. Okay. So we'll be discussing this. Don't worry about this. Just have a look up, just a glance of everything, whatever we are doing. This is the structure which we are going to discuss in the next session. So be ready for the discussion of this structure. If you have any doubts till this point, be free to ask me either through the comments or through any media which you are comfortable. Okay. Thank you for listening.